Hi, everybody. Brad Truax here from Eastman's Woodlands and Wildlife Committee. And today we're going to be talking about some of the trees of Eastman. Specifically, this session is going to be on the conifers. The trees and forests are the heart and soul of Eastman. Eastman's founders designed this community to live within the natural beauty and features of the land. And our trees don't just provide us with shade, they provide us with life. They provide roosting and nesting habitats for both birds and many mammals. Their wood, branches, leaves, nuts, and seeds provide food source for many wildlife species. And you may not recognize there are also millions of caterpillars that feast on tree leaves and in turn become a prime food source for fledgling birds. Woodpeckers often feast upon the insects that are in many of the dying trees. And trees provide shelter from the elements for many wildlife species. Trees are also true carbon sinks that fight global warming and climate change. And even in death, trees provide new life to emerge. So, in a word, trees are Eastman. Eastman's forests are mixed hardwood conifer forests, and our vibrant fall foliage is due to the deciduous trees. But the conifers are evergreens that have year-round functions. And we're going to talk about the conifers today. One of the most common trees at Eastman is the eastern white pine. And these iconic trees can grow well over 100 feet tall. Their straight trunks made them very valuable for ship masts and poles. And they're the source of the green pollen that often lands on everything in the spring or summer. I was just out there today, and my white car is almost green because of all the pollen that's falling from the pine trees. And many birds, like woodpeckers, turkeys, crossbills, and animals like squirrels and deer, even eat the pine cones and their seeds. So here's an eastern white pine. They can grow as tall as 150 feet. They usually tower over the other tree species. So much of the canopy of the forest is made up of the eastern white pine. And their girth can be as much as 10 to 16 feet. Some of these are really huge. White pine needles versus red pine needles. Again, the two pines that we have here at Eastman are the white pine and the red pine. The needles come in bunches that are called fascicles. And on the top are white pine needles. They come in bundles of five, 1, 2, 3, 4, 5. And on the bottom, the red pine needles basically come in bundles of two. And it's interesting, if you try to bend them with your fingers, the red pine needles will break in half. White pine needles won't. They just kind of roll up in a ball. White pine versus red pine bark. The white pine bark is kind of a purplish black with very broad ridges. And on the bottom here, the red pine bark is a little bit flakier and it has these red tinges. You probably cannot pull the bark easily off a white pine, but again, you can probably pull some of this flaky bark off the red pines. And you may, very interestingly, Ethan Tapper, who's a forester in Vermont, says that if you see an isolated red pine in the forest, you can almost always find signs of bear activity on it. So he describes that the bears will come up, they'll scratch at it, leave some claw marks, turn around, start rubbing their back and their neck and their head against it, and then turn around and bite on it. So very interesting observation. Next time I see an isolated red pine, I'm going to go look, see if there's signs of bear activity. So the eastern white pine, the branches grow in what are called whorls. These are actually rings of branches that grow in a circular pattern around the main trunk. And it's interesting that one whorl represents the growth for each year. So you can actually tell how old a white pine tree is by counting the number of whorls. And this is a picture that's demonstrating it. So if you count the whorls down here, you may have to look at basically the knots. Then up higher, you'll actually look at the branches. And if you count them, you can figure out how old that white pine tree is. Very interesting. Most pines, as we mentioned, were valued because they had tall, straight trunks. So they made good sail masts and so on. But sometimes we'll see a pine out there that looks kind of like this. It's either got a trunk that's bifurcated, or in this case, it actually has multiple different trunks. And this indicates that this pine was attacked by the white pine weevil at a very young age, and that led to bifurcation of the trunks. Pine cones, usually when we talk about hard mast, we're talking about things like acorns and beech nuts. So we're usually talking about nuts that come from hardwood or softwood trees. But in fact, some of the conifers produce pine cones that actually are a form of hard mast. So in reality, those pine cones really should be considered hard mast. Many birds, such as woodpeckers and turkeys, and animals like squirrels and deer, will eat the pine cones and their seeds. Many remember this back in 2024. We were deluged with pine cones. They were just all over the place. The pine cones that you see on the ground are the female ones. So you see them here. The male pine cones are these small yellow ones that open up and release the pollen. So why were there so many pine cones last year? Well, there was a bumper crop of pine cones last year. And our white pines probably do have mast years. If you remember in our talks about hard mast, the oak trees produce acorns in a cyclical pattern. Beech trees produce beech nuts in a cyclical pattern. Well, the pine trees probably also have a cyclical pattern for their production of pine cones. So they have mast years where they produce a large number of pine cones every few years. And 2023 was likely a mast year for those pines. And once again, all those pine cones that you were seeing were actually the female pine cones. They're the ones that produce the seeds. And the male pine cones are those small yellowish ones that grow in spike-like clusters and produce the pollen. And when they fall off the trees after pollination, usually in mid-May or early June, we'll see lots of that green pollen covering everything. Squirrels and some birds will feed on those pine cones, and some birds' beaks are actually well suited for extracting the seeds from the pine cones. So, for example, turkeys and quail actually readily seek and eat those pine seeds from those pine cones. So where does all that pollen come from? So again, the pollen comes from the male pine cones. And on the top here, you see, this was early in this current May. You can see the male pine cones here. Here, this is now mid-May, and they are opening up, and they're producing all this pollen. You probably can't see this real well, but this is the pavement on my driveway, and it's literally covered with green pollen. So do wildlife species eat the pine cones? Well, yes, they do. Squirrels and some birds feed on the pine cones. And as we mentioned, some birds have beaks that are ideally suited for extracting the seeds of the pine cone. So turkey and quail in particular. The red squirrels are very fond of pine seeds, and they often stack high piles of pine cones. In fact, a red squirrel once stashed over 50 pounds of pine cones under the hood of a car. What's the value of pines for wildlife? Well, many birds, woodpeckers, turkeys, and squirrels and deer do eat the pine seeds, as we mentioned. Deer, snowshoe hares, and other mammals browse on the needles and the bark. Beavers, porcupines, rabbits, and mice will consume the bark. The dense foliage and branches serve as nesting sites, roosting sites, and shelter from predators. And they provide habitat for cavity nesting wildlife. And they allow shade-tolerant species to grow in the understory. And those trees in the understory may have additional value for wildlife. So the pines are very valuable for wildlife. Now, many of you have also noticed that some of the pine needles have been turning brown. That's probably due to white pine needle blight. That's due to at least 4 fungal pathogens. And it happens after a period of heavy rain in the spring, followed by a dry period. But it's not this year's rain that caused it, it's last year's rain. So once again, I suspect this year, because we've had very heavy rain in the spring, we could be in for another bout of white pine blight in 2026. So again, this white pine needle blight, or white pine needle disease, as some people call it, is caused by those four fungal pathogens. And it follows wet weather in May, June, and July when the white pines are flushing out new growth, followed by a dry season later on. And again, it was last year's rain that triggered the current bout of white pine needle blight, not this year's. But as I pointed out, since we're in the midst of another wet spring, we may well be in store for another year of white pine needle blight in 2026. And this condition may actually be increasing due to climate change. Climate change so far has been marked by periods of increased precipitation, followed by fairly prolonged drought spells. So the trees will likely fully recover, though if we do have several consecutive years of this type of a pattern, it may lead to some pine trees dying. Eastern hemlock is actually the most common tree species here at Eastman. Well, when we ask people what do you think is the most common tree here, we often hear white pine. It's actually the eastern hemlock. And eastern hemlock is a foundation species, more on that. But what it means is that much of the ecology of the forest around eastern hemlock is dependent upon the eastern hemlock itself. These are the most shade-tolerant trees in the East, and they have very long lives. They're what we call a late succession tree. They don't appear early in the succession of a forest. They come on much later when there's a good canopy above them. And they can grow as high as 100 feet and up to 4 feet in diameter. And the branches often form a dense canopy that blocks all the sunlight to the forest floor. So there are very few understory plants, but they do intercept the snow, so they make for very good deer yards or protection for other species like turkeys. So again, they're late succession, very shade-tolerant trees, and their dense canopy blocks out much of the sunlight, so only certain things can grow on the understory. And they're a true foundation species, meaning that they influence a very wide ecology and they provide a habitat for a wide variety of wildlife. So again, several things help us identify eastern hemlocks. They have two rows of very soft, short, flattened, dark green needles on each side of the thin twigs. And the needles have blue-white undersides, and they're unique amongst evergreens in that these are what we call stalk needles, meaning they're on very short petioles. A distinctive trait of the eastern hemlock is they tend to droop downward, and this downsweeping nature is very characteristic. Many of the other evergreens that we see will tend to go upward. So again, this is kind of unique. And the branches do form a dense canopy. And once again, it blocks out much of the sunlight that's going, that would have gone to the forest floor. So again, they also intercept the snow and make for very good protection of animals such as white-tailed deer in the winter. And the cones are very small. They're only about 3/4 of an inch long. And the hemlocks also have very high tannin content. So if you have hemlocks that are near a stream, that stream is probably going to have a deep reddish-brown discoloration. And the hemlocks also have very shallow root systems. So this is, again, showing the hemlock needles, typical needles here. The needles are very soft, they're flat, they're blunt, they're flexible, and they're about 1/2 inch long. And they're rounded at the tip, kind of a dark green on top and a paler silvery color on the bottom. And in the spring, you may see these lime green tips on many of the hemlock branches. Once again, this is showing those needles. Again, they're flat. The leaves stick up in the middle of the stem. They look like little ski jumps. People have described these as ski jumps. And the needles are rounded at the tip, and they're dark green above and kind of a pale silvery below. And each individual needle is attached to the stem with a little wooden peg called a rachis. The needles move out on each side of the stem, And you'll notice on the underside, this is the underside, you'll see these two white streaks, two white lines, often called parallel racing stripes. This is highly characteristic. These are called stomatal bands, and it reliably helps you identify these needles as belonging to an eastern hemlock. Eastern hemlock cones, once again, are very small. They're only about 3/4 of an inch long. They do tend to hang downward, and that's in distinction to the balsam fir, which has fine cones that go upward. And red squirrels, as we mentioned, are very fond of the cones. The eastern hemlock bark is sort of a reddish purplish brown, and the furrows in the bark become much more prominent as the tree ages. As we mentioned, hemlock is a foundation species, and that means it defines the ecosystem around it. And because of that, any threats to the hemlock, like the hemlock woolly adelgid, can have a widespread impact on the whole ecosystem. Hemlocks actually were widely destroyed about 5,000 years ago, but subsequently recovered many years later. And some suspected that that was due to an insect or other pathogen, but yet others have suspected it might have been related to climate change. Prolonged drought may have led to the widespread loss of the hemlocks. Hemlocks are very drought intolerant species, and they have high moisture requirements. And they like cool, moist, shaded ravines, such as the Catamount area here at Eastman. So again, once again, as a hemlock, as a foundation species, the rest of the ecosystem around the hemlocks are really dependent on the hemlocks themselves. And hemlock stands create unique microclimates. With their dense canopies, they provide shade, cooler soil temperatures, and higher humidity. And that influences the growth and survival of the understory plants and any animals related to them. And sphagnum, mosses, and ferns often grow in that understory. And those shade-tolerant plants beneath them would die off if those hemlocks were not there. And it likes cool, moist, shaded areas such as the Catamount area here at Eastman. And if you step into a hemlock grove, you'll readily feel a drop in temperature and an increase in the moisture. So again, hemlocks are very important for wildlife. Porcupines, especially like hemlocks, and if you find many hemlock branches on the ground floor in the forest, it'd be a good sign that there are probably some porcupines nearby. And deer and moose will browse on the hemlocks, and the branches, buds, and barks that fall to the floor do provide food for deer, snowshoe hares, rabbits, mice, grouse, porcupines, and undoubtedly some other species. And red squirrels, we mentioned, are very fond of hemlock cones. The hemlocks also capture the snow and block the wind, so they provide shelter for many species, particularly for white-tailed deer, for turkeys. And the hemlock stands also reduce the depths of the snow and help them moderate the temperatures, so that provides a very important consideration for the deer in winter. Many songbirds also breed in the hemlocks, and cavities in the hemlocks can provide shelter for a number of species, not just birds, but cavity-dwelling mammals as well. And the hemlocks also cast a very deep shade over streams, and that ends up cooling the water so that cold water fish like brook trout can actually thrive in those streams. So hemlocks very important in winter. They capture the snow and block the wind, so that provides shelter for deer, turkeys, porcupines, and other species. And once again, because they can reduce the snow depths underneath them and help moderate the temperatures, that provides a particularly important deer wintering habitat. So this is showing a deer yard in winter. Deer often congregate together in what are called deer yards. And the eastern hemlocks often provide shelter in those deer yards. They intercept the snow and block out the wind. This is showing the same thing for turkeys. Turkeys remain active all winter long, and they forage, interestingly, in groups by sex. So the adult males will be together, the young males together, the females together. And the deep snow makes it somewhat difficult for them to find food, but they often roost in conifers to protect them from wind and predators in the winter months. So once again, regarding streams, hemlocks have two key impacts on streams. We already mentioned that they cast a very deep shade over the stream, and that helps cool the water so that cold water fish like brook trout are able to thrive in those areas. And secondly, because they have a high tannin content, the nearby streams are going to have a deep reddish brown discoloration. So again, we did mention that the eastern hemlocks have a high tannin content, and as a result, they were often used to tan leather, giving it a reddish brown color. The wood actually has very little value as a lumber, but it was sometimes used to make boxes and crates. More often, it was probably used for making pulp to be used for paper. And interestingly, Native Americans often made a tea from the needles, and apparently that tea was very rich in vitamin C. Now, there is a threat. Our hemlocks are under threat from the invasive insect, the hemlock woolly adelgid. This is a tiny insect that basically inserts its straw-like mouth part into the needles and sucks the sap of the hemlocks. And as a result, it steals the nutrients that are needed by those needles, and the needles ultimately will fall off. And the hemlocks don't die immediately, but they'll eventually die as the infestation gets worse. And the adelgids cover themselves with this white cottony substance that makes it easy to identify an infested tree. Okay, so that's hemlocks. Spruce are probably the next most common evergreen or conifer that we'll see here at Eastman. And the spruce is an evergreen that has this very familiar conical shape. They grow relatively rapidly, and they can reach heights of up to 60 to 90 feet. They can actually live 100 to 250 years or even longer. And their needles are short, blue, green, and waxy in appearance. They are coniferous evergreens, and there are actually about 40 species of spruce trees, but red spruce is the most common species that we have here at Eastman. Red spruce is a very rugged species. It's very shade tolerant, especially when it's young, and it grows slowly. But if something happens to the forest, like a fire or something like that, the red spruce can actually shoot up and actually go right up into the canopy. And they can live for over 250 years. This is showing a red spruce. The average height is about 60 to 75 feet. Diameter is only about 1 to 2 feet. And once again, they can live long periods of time. Actually, before I said 250 years, some people say they can be 350 years old or even longer. And they have, again, shiny green needles that are four-sided. And the bark is kind of a dark purple-black color and very flaky, almost as flaky as the black cherry bark. You'll probably remember from some of our discussion about other trees, particularly the deciduous trees, the bark of the black cherry is often referred to as looking like burnt cornflakes. So once again, the red spruce often has this very flaky bark that does somewhat resemble the bark we'll see on black cherry trees. Spruce needles are four-sided. They're attached singly to the small, persistent peg-like structures called pulvini, and those pegs actually persist after the needles have dropped off. Here in this lower picture, you see the needles are gone, but you see these little kind of wooden pegs there. And the needles are rounded and tips are very sharp, okay? Unlike the needles that we'll see either with the eastern hemlock or with the balsam fir, which are flat and very soft, the needles of the spruce needles are much sharper and they're rounded, and you can actually roll them between your fingers, whereas you cannot roll the needles of the balsam fir or the eastern hemlock. So again, note the symmetry of these spruce branches. Okay, very symmetrical. These branches come off opposite to each other, often at 45-degree angles. And this is just showing some differences between the red spruce and the balsam fir. In particular here, the one I want you to remember is the cones. The cones in the spruce hang down, cones in the balsam fir go upward. Now, there are other differences that we'll talk about in a minute. In terms of the needles, the spruces have, again, square four-sided needles that are relatively stiff. They grow all the way around the fat twigs, and they're distinctly sharp and prickly. So if you pick them up, you can readily determine that they're prickly. And that's as opposed to the soft feel that you would get with either balsam fir needles or eastern hemlock needles. And the firs do have, I'm sorry, the balsam firs have flat two-sided needles, and they're much softer, and you can't roll them between your fingers. Whereas the spruce needles, if you're able to roll them, you can roll them between your fingers. Here's the spruce cones. They hang down, and they have scales that make them smoother to touch than the pine cones that we discussed before. And the cones are usually about 1 inch to 1.5 inches long. Once again, this is showing some differences between the spruce and the fir, and this is highlighting difference in shape, again, between the two, and the bark is different. And I'll talk specifically about the bark differences in a minute. So again, spruce trees are more rounded compared to the pointy firs that have a spire-like look. And spruce bark is plated, whereas the fir bark is smoother, though it has what we call pitch pockets. And spruce needles are four-sided and pointy and sharp, as we've discussed, compared to fir needles, which are flat and two-sided and much softer and flexible. And spruce needles attach to the branches with a small stem, whereas the fir needles attach directly to the branches. Spruce branches tend to curve down and then up, so they go down and then curve upward. And spruce cones hang downward, whereas the fir cones face upward. So what are the uses of red spruce? Well, red spruce wood is relatively soft, so it doesn't make, not particularly valuable as a lumber source, but it may be used for making pulp, which again can be used for making paper. And spruce, again, are commonly used as Christmas trees. Red spruce does have value for what's called tone wood. So, for instance, instruments like guitars, violins, and soundboards that have to maintain a quality tone, red spruce happens to be a pretty good wood for those instruments. But spruce is definitely a value for wildlife. It provides lots of food and cover for a variety of mammals and birds. It provides that winter cover for white-tailed deer, as we talked about. The red squirrels, again, will eat the buds and the seeds. Mice and voles will consume and store large amounts of spruce seeds. Porcupines may feed upon the bark in wintertime. And the red spruce provide food and nest sites for a number of birds as well. Okay, the last conifer that we'll talk about this morning is the balsam fir. Balsam fir is an evergreen. It's got a more pointed spire-like shape. They can grow to heights of about 40 to 60 feet. Diameter might be as much as 3 to 4 feet, but it's much more common to be on the average of 1 to 1.5 feet. And the needles are flat and two-sided, and they're soft, and they cannot be rolled between the fingers, unlike those of the spruce trees. The balsam fir, again, has that more pointed spire-like shape, so it's popular for Christmas trees. But actually, most of those Christmas trees that are balsam fir are actually grown on plantations rather than taken from out in the forest. Again, the ones out in the forest are probably too high to keep in most homes. So once again, they can grow as high as 40 to 60 feet, and they're very shade tolerant. They tend to grow in cool climates that have consistent moisture at their roots. And once again, the needles are flat, they're two-sided, soft, and you can't roll them between your fingers. They also do have two bright white bands on the underside, kind of similar to what we see with the eastern hemlock. And the bark is thin and gray and smooth. It has many of things we call pitch pockets, which are actually blisters that contain resin. I'll show you those in a minute. And the cones are very characteristic. They're purple colored, they're about the size of your thumb, and they tend to point upward. So they're very unique amongst the conifers in that the cones face upward. And they're known for their aromatic, pleasant, sort of Christmassy smell. Once again, here are the needles, and you can see that the needles do have these white lines on the underside. And again, they're attached kind of directly with these things that almost look like suction cups. Once again, you can't roll them between. And here again are these little things in this inside here. They look like little suction cups. And here's the balsam fir bark. So once again, it's smoother than that of spruce trees. And it's common to see these pitch pockets, are also known as resin blisters. And you can actually pop these open. You got to be real careful you don't get this in your eyes. And those blisters contain a very sticky, fragrant liquid resin. And this is showing those pine cones I talked about. The pine cones are purplish in color, and they tend to grow on the branches especially near the top of the tree. But unlike all the other conifers, their cones point upward. And again, they're typically pretty small, anywhere from 1/2, maybe as much as 3 inches long. And once again, they tend to disintegrate in place on the tree as the individual seeds ripen and are released. So those cones, rather than falling to the ground, tend to disintegrate right on the tree. And most of the seeds are dispersed by the wind, but small mammals may play a supplemental role in dispersing the seeds of the balsam fir. Balsam fir does have value for wildlife. It provides food and cover for many mammals and bird species. Once again, it can help provide some shelter for white-tailed deer, moose, snowshoe hares, ruffed grouse, and other small mammals and songbirds. And its foliage is browsed by moose and deer, particularly in the wintertime. And the seeds, again, are eaten by red squirrels, grouse, and pine mice. And its needles are eaten by some caterpillars. Once again, we often don't recognize how many caterpillars we have out in the forest, and those caterpillars subsequently become good meals for fledgling birds. And they, again, play host up to 114 species of moth and butterfly larvae, basically the caterpillars that we were just talking about. So that's a bit about the trees of Eastman. We will discuss some of the other trees, particularly the deciduous trees, in another presentation. We hope that you've gotten something out of this. Enjoy your day.